So I had mentioned to you that you have this project coming up, right? And this is where we begin developing what you're going to need to be able to do on this project. So it's super, super important that you pay close attention. If you get lost on something, raise a hand and ask. I'm more than happy to go back over it with you, okay? But this is where we begin the process of teaching you the things that you need to know so that you can put your whole presentation, your video project together. Because what we're doing today, you'll be doing in your project just in kind of a unique and different sort of way. So you got to pay close attention to what we're doing, okay? Super, super important that you stay focused, all right? Now, you can see by the title of the lesson here, we're going to be constructing something called triangle centers, okay? There are a lot of different centers for triangles, and we're going to be looking at a few of them. Prior to our project, we're going to be looking at 3 key centers. These are just really key points that all triangles have in common. Okay, and so we're going to use our construction skills to find these points, and then you'll learn some things about them in terms of their relationships to each other and to other things, and that will lead us to your project. So I'm going to kind of zoom in just a little bit here on the notes. All right, so let's talk about the first center that we're going to learn about. Oh, sorry. Yeah, take that out. There we go. Okay, the first center that we're going to look at is called the circumcenter, C-I-R-C-U-M, center. And after circumcenter, I want you to put in parentheses a letter U. Make sure it's a clear U, not pointed, like a V. Make sure it's a clear U. Okay, the circumcenter, we're going to identify with the letter U. It's a point, okay? Now, here's where your vocabulary is going to come into play. I'm going to write some things down. I'm going to talk about some things here. I want you to think about what you know and sort of visualize what we would need to do in order to find this circumcenter, right? Okay, so the circumcenter of a triangle is where the segment bisectors, you know what those are, where the segment bisectors of the triangle's sides intersect. The segment bisectors of the sides of the triangle. Where those lines intersect, you're going to find the circumcenter. Now, there's some unique mathematical components to the circumcenter. Number one, it is equidistant. We saw that the other day. Equal in distance from the vertices of the triangle. Let's just be real clear. We'll just say this one time. The vertices, when we say that, we mean the corners of the triangle. Okay? It is equidistant from the vertices of the triangle, and it is the center of a triangle's circumcircle. It's something we're going to create. There's a lot of circles. Yeah, it is. Yeah, it is. We got the circumcenter. Well, actually, if you think about the connection there's a lot of circumcenter, right, would be the center of the circumcircle. That would actually make sense, the language, right? Okay. You guys know what a segment bisector is, right? We just did that, right? If I asked you to bisect a segment, we could do that, right? In fact, I'm going to zoom out just a little bit here, right? So how about if I gave you like a problem like one we were just working on the other day, right? Let's just pretend I covered this up, and all I gave you was this line segment right here, and I said, hey, I want you to create the segment bisector for that line segment up there. Could you do it? Yeah. You should be able to. Yeah. Okay. Why don't you create the segment bisector for that line segment, which happens to be the left side of that triangle? Go ahead. Let's see what you got. Give it a shot. You should have come up with that guy right there. How'd you do? Yeah?
It's not what I look like.
Yes.
So if you're finding the segment bisector of this side of the triangle, you're going to set your compass point at one corner, one vertex, open up more than halfway, arc above, arc one side, arc the other side, flip your pointer around, arc the other side, arc the other side. You'll get your crossing arcs, and then you draw a nice long segment bisector line. Well, that's easy, right? That's the same thing we just did on the homework.
Yes.
Okay. Then why didn't you find the segment bisector for the bottom part of the triangle?
Okay.
Let's find the segment bisector for the bottom part of the triangle. Go ahead.
Oh, wait.
Okay. You should have come up with that line right there.
Oh, yeah.
And again, you can always double check if you need to, right? Like by opening your compass and checking and making sure that it matches, right? Now, here's the thing. The circumcenter is found where all three segment bisectors intersect at the same place. But as a good little checkpoint, we already got two lines intersecting. If we did this right, then our third line should pass right through this intersection as well, right? That would be, but here's the thing. That's only going to serve as a checkpoint for us. So you still have to create the crossing arcs on both sides of the lines. Did you hear that? Yeah. I'll repeat it one more time. You still have to create the crossing arcs on both sides of the third side. You can just use this intersection as a checkpoint to say, hey, I got it in the right place. Okay, go ahead. Do that last one. Okay, you should have come up with that construction right there. Yeah? Good. Okay, now pay close attention. Here we go. Watch. Shh. All right, now, as I mentioned, where the segment bisectors of each side intersect, the three segment bisectors, that point right there is called the circumcenter, and we're going to label that point with a U. And we're going to be consistent. Anytime we construct a circumcenter in the next several lessons, we're going to use a U. So when you use a U on your graph, that means that we're talking about the circumcenter, and that's what I'm going to grade your paper. So you need to make sure to use the correct letter to identify your circumcenter, okay? Now, one of the things that I want you to be able to do is indicate to me clearly that you know the three line segments that produced your circumcenter. And so what we're going to do is we're going to color all of our bisector segments one color. And so listen, carefully listen. We're going to use one color every time we do a circumcenter. So segment bisectors in every lesson that we do for the next few lessons is going to be one color. You can switch it up between lessons, I don't care. But I want you within a lesson to use one color for all circumcenter construction. So like for example with this one, all right, I'll use orange and I'm going to use a highlighter so it's a little bit brighter. So I'm going to take my ruler, I'm going to line it up just a little bit off my segment bisector. And I'm going to take my highlighter, and I'm going to highlight my segment bisector, orange. That was a little thick. I'm maybe do it a little narrower. And then I'm going to come over here. I'm going to highlight my segment bisector. That's a little bit better. Orange. And then I'm going to come over here, and I'm going to highlight my segment bisector, orange. Okay, so now I've indicated the lines that formed the circumcenter. So when I look at your paper and I grade your paper, I'll see one set of color of lines that all intersect at a U, and I'll know that you know that those are the segment bisector lines. They're cutting the sides of the triangle into congruent parts, okay? And I'll also know that that point in the middle there is the circumcenter, okay? All right, here's what I want you to do. I want you to label all of the vertices of the triangles and all of the midpoints of the sides of the triangles with letters of your choosing, except, are you listening? Except for, right here, you'll see on this question, it says, you don't get to use U, H, S, or N. Those are all reserved for special things in the next few lessons. U, H, S, and N. It's written right here. Okay? Like, for example, U is the circumcenter. We'll only use U for the circumcenter. You get to choose whatever other letters you want. Just know U, H, S, or N. I want you to label all of the vertices and midpoints of the triangle in this construction right here. Go ahead, get started. You can do it. If you need a little hint, it would look something like that. Vertices and midpoints of your triangle.
Guys, that was so simple.
Here's an example of what you should have come up with. Now, you can use different letters than me. That's fine. As long as you didn't use U, H, S, or N. That's fine. All right, now, what I want you to do is I want you to place congruence marks on the segments that you know for sure are congruent to each other. Okay? Without doing any measuring or anything like that. If you know for sure that there are segments on that triangle that are congruent to each other, I want you to mark them. Okay? With congruence marks. Only what you know for sure. You should have done something like that.
Yeah, none of them.
Why can I put congruence marks between A and D and B?
Oh, because you bisected them.
Because I bisected A, B, and D is the what?
Oh.
The midpoint. Oh.
Oh my God.
All right. Okay. All right. So then I should be able to say that BF is congruent to FC, right?
Yes.
And I should be able to say that AE is congruent to EC. Yeah? Is that good so far? Yeah. Okay. Now, this is labeling vertices, labeling midpoints, marking congruent parts. That's going to be something that you do on a lot of things. But there was something else that I told you that was special about the circumcenter. What else did I tell you was special about the circumcenter? Equidistant from what? Okay, all right, let's see if that's true. Take your pointer and put it right in the middle of your circumcenter. And then let's use, we'll just use this bottom corner here, C. Let's open our compass pointer so that it goes right to the corner C here. And then let's lock that down. And then what you should be able to do is that you should be able to use your compass pointer. If that's the distance from the circumcenter to C, rotate it around over here. Look at this.
Can you draw a circle?
It's the same distance to A. Wait, it's the same distance to B.
Oh my.
It's not just a circle. It's the circumcircle.
Oh my gosh.
Can we draw the circle?
Draw the circumcircle. This is the circumcircle. Draw it.
This is quizzy. This is quizzy.
So the circumcenter is the center of the circumcircle, which totally contains the corners of the triangle within it. Okay, let me bring you back a second. Everybody look up at the screen. Everybody looking up at the screen? Okay, look up here, fish. Look up here. Okay, look. Check it out. Here, in this construction, we started with a circle and we inscribed a hexagon into it. We also did it with an octagon and a dodecagon, right? Inscribed, inside writing. However, we could say that this circle is circumscribed, outside writing, around the hexagon. And this time we created a circumscribed circle around this triangle. There you go. There you go. Now, you can draw a circle around any triangle. Brody, that's not what that's for. Okay, let's focus. You can draw a circle that contains any triangle, and the easiest way to do that is to find the circumcenter. That's how you find the circle that contains the triangle. Okay? All right, let's talk about instructions for your practice problem that you're going to do right now. Okay? Here we go. Ready? You're going to construct and highlight the segment bisectors of the sides to find the circumcenter and circumcircle.
Oh my God.
You're going to label the circumcenter U. You're going to label all the vertices and midpoints, not using U, H, S, or N. And you're going to mark all congruent segments.
Which basically everything we did not.
Yeah,
Yes,
exactly.
yeah.
We're going to construct the circumcenter and the circumcircle. Okay? I'll let you have at that. I'll give you some step checkpoints along the way, okay? Hey, just so you know, watch up here real quick. Just so you know, I'm going to go left side of the triangle and then bottom of the triangle and then this kind of top part of the triangle. So if you want to like follow along with hints, if you want to do it in the same order, that's the hints I'll reveal.
I
All
got
right?
this.
Okay, go for it.
You want us to highlight it and everything too? Well, you said you got it. Okay.
Okay, checkpoint 1, you should have gotten this construction here.
Oh my gosh, I'm cooking right now.
All right, checkpoint number 2, should have gotten here, and you're discovering that your circumcenter is actually not inside the triangle at all. Outside the triangle.
Look at Jackson, my circle. Is this? Oh. Yeah, everybody.
All right.
People that are in your group get it.
Did you get that final construction right there? All right, good. Okay, get it all labeled up and highlighted and ready to go.
I bet I knew it.
Keep on typing.
Get me the brown.
All right, here we go.
Also, what was this okay, Kevin.
There's your final construction right there.
Yes.
Good?
Guys, you guys like my Halloween color?
Okay, now, listen, let me show you something real quick.
He said one color.
Yeah, I want you to have one color for your circumcenters.
It is one color. It is one color. I have 4.
So the idea is that you would have a color assigned for your circumcenter. Okay, look. Couple things I want to point out. You ready?
Yeah.
Watch. It's important that you indicate to me the points. Kyler. Okay, it's important you indicate to me the points that are the midpoints and the correct congruent segments by centering your congruence marks, because there are other places like here where a segment bisector line crosses the side of a triangle. But I want to make sure you're clear that that's not a midpoint right there. Okay, and so you need to know that, and that's why I'm having you label your midpoints so that you communicate clearly to me. I understand that this is the midpoint of this segment bisector. I understand this is the midpoint of this segment bisector here, well, the midpoint for the side of the triangle. Okay, that's what I want to make sure you're clear on, so that these other two intersections, you know, don't have anything to do with midpoints. Okay? Any questions on the first center of the triangle, the circumcenter? Everybody good? All right, let's work on the second one. Okay, so now a different triangle center. This one that we're looking at is called the centroid. It's C-E-N-T-R-O-I-D, centroid. And in parentheses after that, I want you to put an S. Well, now you can start to see why we've reserved some of these letters. So our circumcenter was U. Our centroid is going to be S. All right, now, the centroid of a triangle is where the medians of a triangle intersect. A median? What's a median?
It's like a median mode.
Well, a median of a triangle connects a midpoint of the side of a triangle to its opposite vertex.
Wait, did you write median of the that they're both median?
Mm-hmm. So the centroid of a triangle is where the medians of a triangle intersect. Okay? All right, see ya. And a median of a triangle connects a midpoint of the side of a triangle to its opposite vertex. A midpoint, right? Like if I covered up this part of the triangle here and I had just given you this line segment and I said, hey, I'd like you to find the midpoint of that line segment. Could you do it?
Yes.
Sure. Well, are you going to draw a whole line through the arcs? No. Oh, this is the second instruction that we did. Okay. Find the midpoint of all three sides of the triangle and just mark the midpoint. Okay? Ready to go. I'll give you steps. Okay? Go ahead.
What?
Okay, if you're moving in the right direction, you should have been heading this way. Finding the midpoint of the three sides of the triangle. Go ahead, keep going. All right. If you found your three midpoints, your triangle should probably look something like this here. Okay. Now, a median line connects a midpoint to its opposite vertex. All right, here's what I want you to do. Okay, right now I want you to use one hand and I want you to put your finger at this midpoint right here. Okay, so put your finger at this midpoint. Okay, now, with your other hand, I want you to put your finger on the vertex of the triangle that you think is opposite this finger right here. So you're going to put your finger here at this midpoint. What vertex do you think is opposite of that? You should have put your finger out here. That's the vertex that's across the room or opposite from this midpoint. This midpoint, this vertex, yeah? Okay, draw a line that connects the midpoint back to its opposite vertex and do that for all three midpoints. Create all 3 medians. All right?
They don't line up right.
Then you didn't do it.
That would be the correct answer, Sophia.
What?
All right, if you constructed your centroid, your 3 medians, you should have found your centroid right there. And that we're going to label S. That's point S because that's our centroid. So let's label that S.
Well, S is the centroid.
S is going to be our centroid point. All right, here's what I want you to do. I want you to highlight your medians in a different color from your circumcenters. So pick a different color that you didn't use for your circumcenter and highlight your medians, all 3 of them in the same color. And then I want you to label all your vertices and midpoints not using U, H, S, or N. And then I want you to put congruence marks on the sides you know for sure are congruent. All right, you got a lot of work to do. Ready to go. So let's take a look. Here's what I came up with here. Okay. Everybody good so far? All right, now, I want you to find on your drawing the equivalent to my segment SR.
Huh?
This is my segment SR right here, right? With the little stretch of the line that stretches in between there, which is on my median, right? It's on median MR. Okay. Now you got yours. You got where yours is identified. Okay. So what I want you to do is I want you to find the midpoint of this piece of median, what I would call MR. So I'm going to find the midpoint between segment S and R. So I want you to find the midpoint of segment SR or whatever it is on your paper. Okay. So the long part of the median here of median MR, I want you to find the midpoint of that line segment right there from S to R. Find the midpoint of that line segment. Go ahead and do that. This right here. So you see I got my crossing arcs to find my midpoint and I called it V. Yeah, look good? All right, now here's what I want you to do. Set your compass pointer at your centroid. Loosen it just a little bit because I want to check the measurement and make sure that our midpoint is actually halfway. So let's set our measurement to that midpoint. Set your measurement to this midpoint. Right, Brody? You are?
Ready. Oh, yeah.
Okay. Now, let's check and make sure from S to V is the same as from V to R. Right? When we find our midpoint from S to V, should be the same as from V to R. Mine's a little bit off here.
Mine's a little bit off too.
And what you'll notice is it's the same as from the other side here, S to M. So what the centroid does is it splits a median into 1/3, 2/3. So if from M to S here is X units long, S to V is going to be X units long, and V to R is also going to be X units long. So the long part of the median is twice as long as the short part of the median where the centroid breaks it into pieces. So the centroid, like, we talk about midpoints break a line segment into 2 equal parts. The centroid breaks the medians into a 1-to-2 ratio part. And that works on all of the medians. And so that's kind of the mathematical component of your centroid point. So when you construct all of your centroids, you're going to do everything we did on this one, and then you're going to pick one of them, and then you're going to cut it, and you're going to find the midpoint of the long one, and that should split it into 3 equal parts that you'll verify and label here. Okay, does that make sense? So this is like the making of your circumcircle verification that you found your centroid correctly. Everybody good? Know how to do it?
Yeah.
Okay, then I want you to do this one down here, okay? So this is your checkpoint problem down here. You're going to find the medians to construct the centroid. You're going to label it S. You're going to label all the vertices, all the midpoints. Put your congruent marks. Don't use U, H, S, or N for your vertices or midpoints. And then find one median. Find the long side of the median from the centroid to the vertice. Bisect it. Find the midpoint. And then check your measurements to make sure that it's cut into a 1:2 ratio. All right, good luck. The answer for this one. It's what I came up with. Take a look and see how you did. I chose what I called median BG. And I can say that segment BS is twice as long as segment SG on median BG. And I showed that on one of my medians. Cool? All right. Good job.